started. Do you have any questions, comments, something to say before we get started? Okay, if not, then we will just continue. So today we are going to formally define the derivative of a function. Now with derivative, what we are basically looking for is the slope or the gradient. Okay, now we want to work out what is the gradient or what is the slope at a specific point on a given curve. So let's say you have your x and y axis like this, and then you have some graph that looks like that. So if I want to work out the gradient at, oh wow, if I want to work out the gradient at a specific point, let's call that point A. What I can do is I can estimate it using a line. Now this line, I pick another point also on the graph, and then I connect them using a straight line. This is the point B, okay? Because I'm interested in the gradient over here at A. So I pick another point, I form a line, and then I will work out the gradient in the normal way, delta y over delta x. Now the x coordinate of A is x. The x coordinate of B is x plus h. Now the reason I make it x plus h is I don't want to pick a B that is somewhere over there that's very far away, because my aim is to estimate the gradient at A. So I'm picking points very close to A, and h represents a small value. Then the y coordinates over there, I will have f of x plus h, sorry, f of x, and then the y coordinate of B is f of x plus h, and this is your function f. Okay, so to get the value, the y value of A, I substitute the x value into my function, and then I will get the y value. Then the same thing with B. So we know that our gradient m of AB, this is just delta y over delta x, and this you can calculate it as f of x plus h minus f of x. This is over x plus h minus x. And if we simplify, in the numerator you have f of x plus h minus f of x, and then in the denominator I will just have x, I will just have h, because this x and that one, they cancel each other out. Okay, now remember what we want. I want to find the gradient at the point A and not a line connecting A and another point on the graph. So what I do is I try and work out what is happening to the gradient if this h is getting smaller and smaller. So in other words, my h is going to 0. So what I'm actually interested in is this, the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so this h represents the distance on the x-axis between A and B. Now if the distance between A and B on the x-axis is getting smaller and smaller, it's approaching 0, it means that eventually B will be the point A. And then using that gradient formula, I will have the gradient of the gradient at the point A, so which is what I want. So this that I've written here, the limit as h approaches 0 of f of x plus h minus f of x over h, this is what we call the derivative, and we denote it like this, f prime of x. This is the limit as h goes to 0 of f of x plus h minus f of x over h. And we say this is the derivative of f of x with respect to x. Okay, so when I ask you to find the slope at a specific point, I'm also asking you to find the derivative. I ask you to find the gradient at a specific point, I'm also asking you to find the derivative, because you can see that the formulas are exactly the same. So when we work out the derivative, all we are working out is the steepness, the gradient, the slope of that function at a specific point. Okay, so gradient is not just limited to straight lines. You can find the slope of curves as well. Okay, now using this definition to work out your gradient, your slope, your steepness, this is what we call the first principle. Okay, so an example of a question you could have is find f prime of x if f of x is equal to x squared, and then it says using the definition. Okay, so we want to work out the slope, and we have to do this using the definition. Now the definition is this one over here, this one that I've circled over there. That is our definition. The limit as h goes to 0 of f of x plus h minus f of x over h. So what you do is you will substitute x plus h over there, and then subtract when you substitute x, divide by h and work out that limit. So f prime of x, this is just equal to the limit as h goes to 0, and then I have f of x plus h. This is that. So remember last week we were doing substituting into functions, and I say that when you substitute into a function, it is not just a number that you can substitute. You can substitute other functions, other variables into the function. So it doesn't just have to be a number. And then f of x, maybe let me write the formula first. So this is f of x plus h minus f of x over h. So this is the definition of the derivative f prime of h. Now when I substitute, I have the limit. Okay. I have the limit as h goes to 0. Now f of x plus h, that means I replace x with x plus h, so I have x plus h squared. And then f of x, this is just x squared, and then I divide this by h. Now last week when we were doing limits, we said one way to find limits is just by directly substituting. Now if you try substituting here, what you have is this will end up as x squared, and that will end up as x squared. This will be 0 as well. So you have 0 over 0. So what you need to do is try and simplify it. Now to simplify it, you can multiply out the brackets. This is the limit as h goes to 0. This is x squared plus 2xh plus h squared minus x squared divided by h. And this one over here, you expand it using Pascal's triangle or the binomial theorem, and then now you simplify. You'll notice that this x squared and this minus x squared will cancel. So let's see what we are left with. So I have limit as h goes to 0. I have 2xh plus h squared divided by h. Now looking at the numerator, I see that h is a common factor, so I can factor that out. So I have limit as h goes to 0. H is there. I have 2x plus h. This is divided by h. Now I have h in the numerator. It can cancel with that denominator because it's factorized. They're multiplying. So those two can cancel out. And what I'm left with is the limit as h goes to 0 of 2x plus h. In the denominator, I'll have 1, and 2x plus h over 1 is just 2x plus h. Then now I can substitute h equal to 0, and then I have 2x plus 0. Notice that my limit over there is gone. As soon as you make the substitution, your limit should not appear anymore. And then this is just equal to 2x. Now this 2x just means that if I want to work out the gradient of a point on the graph x squared, now we know that x squared looks like this. Okay, it touches the x-axis, that's what it looks like. All right, now if I want to find the gradient, let's say at a point here, I will just have to use this formula, 2 times whatever my point x is. So if the point here is 6, then the gradient or the slope is equal to 2 times 6, and this is equal to 12. So the steepness of my curve depends on where I am. So the closer I am here to 0, the less steep it is. So let's say this is half. Over here, the gradient at half this is going to be equal to 2 times half, which is equal to 1. Okay, and if you look at the points, you compare with the graph, you can see that at half the graph isn't as steep as it is at 1. And then if you look on this side here, let's say I pick -4. So the gradient at x is equal to -4. This will just be 2 times -4. This is -8. So it's negative, and that is reflected on the graph because at this point you're going down the hill. All right. So the gradient depends on where you are, and this 2x gives us a formula for the gradient. Unlike with a straight line, the gradient is the same no matter where you are. So on a straight line, if you have that, if you pick this point over there, the steepness is exactly the same as that point, and at every point on the line. But with other curves which are not straight lines, you will see that the gradient is not constant. It depends where on the graph you are. Okay, so that's that one. The derivative is just telling us what is the gradient. And using the first principles, it's mostly just algebra. There isn't anything too tricky to it. You just have to use algebra. Let's look at another one. Let's say I have f of x. This is equal to x cubed minus x. And then I want to find a formula for the slope, okay, so that I can work out the slope wherever I am. Now to do this, I will just substitute my x plus h into the formula. So I have f prime of x. This is equal to the limit as h goes to 0 of f of x plus h minus f of x. This is all over h. Then this is limit. So this limit must be there all the way until I finally substitute h is equal to 0. Now f of x plus h, that means in the original function, wherever I have x, I'm going to put x plus h. So this x will change to x plus h. This will change to x plus h. So what I have is this. It's x plus h cubed minus x plus h. And then I replace, or I substitute this f of x. Now f of x is exactly the way it is over there. So I need to subtract that. So this is minus, and I put it in brackets to show that I am subtracting the whole thing. and then this is minus x. Close your brackets, and then this is all over h. Then to work this out, what you need to do is use Pascal's triangle or the binomial theorem to expand this bracket over there. So I will have the limit as h goes to 0. When I expand that, I will have x to the power of 3 plus 3x squared h plus 3x h squared plus h to the power of 3. So that is the expansion. See the coefficients, I have 1, 3, 3, 1. The powers of x are decreasing and the powers of h are increasing. So x starts from 3, 2, 1, 0, and h starts from 0, 1, 2, and 3. And then I have minus x minus h, that's this one over here. And then I have minus x cubed, that's this one here. And then I have plus x, which is this one. Because of this negative, when it multiplies that one, I will end up with a positive. And this is all divided by h. Then you see, are there any terms that can cancel? Now, if you've done this correctly, you will always notice that the terms that don't have h will cancel. So you'll be able to factorize h out so it cancels with the one in the denominator, especially with polynomials. So you can see this x cubed cancels with that one. Then this minus x cancels with that one. And when I look at all the terms that are left, they all have an h. So I know that I'm on the right track. So this is the limit as h goes to 0. Now what I have left, this is 3x squared h plus 3x h squared plus h to the power of 3 minus h. Okay, that's everything. Then you divide by h. So in the numerator, I'm going to factor h out. This is the limit as h goes to 0. I have h 3x squared plus 3xh plus h to the power of 3 minus 1, and this is divided by h. So then those two cancel each other out. Then I'm left with the limit as h goes to 0 of 3x squared plus 3xh plus h cubed minus 1. Now I can substitute, because when I substitute, I'm no longer dividing by 0. So what I get will be defined. And now that I'm substituting, I no longer need to write the limit. So this is just 3x squared, because that first term doesn't have an h to substitute into. Then I have 3x times 0 plus 0 to the power of 3 minus 1. And then what I will be left with is 3x squared minus 1. So what this means is, if I want to find the gradient at any point on the curve, so the curve was y is equal to x cubed minus x. So if I have this curve and I want to find the slope, let's say at x is equal to 0, what I will do is I will say 3 times 0 squared minus 1. This is equal to minus 1. So when x is equal to 0, your graph is decreasing. You're going downhill. That's what this means. So other functions, apart from straight lines, they do not have a constant gradient. You'll find at some points you're going uphill, other points you're going downhill. And this derivative just tells us what the formula for finding the gradient is at a specific point on the curve. Okay, let's try another one. Let's say I have y is equal to x plus 1 over x. And the same thing here, I have to work out the gradient, the slope, the steepness, the first derivative, using first principle. Now, first principle, it is a must that you use the definition, Now there are shorter ways that we'll look at after this, but you need to know the techniques of using the definition. So here, if I want to work out y prime, which is also equal to f prime of x, I'm working out the derivative. This is equal to the limit as h goes to 0. Then what I do is I will substitute x plus h here. I will substitute x plus h over there. Then what I have is this. I have x plus h plus 1 over x plus h, and then I subtract this the way it is. So minus, let me just write it at the bottom here, minus, and I put it in brackets to show that I am subtracting the whole thing. That's what I have. And this is still over h. This is the definition. Then I try and simplify as far as possible. So this is equal to the limit as h goes to 0. I have x plus h plus 1 over x plus h minus x minus 1 over x. This is all divided by h. Then see anything that can cancel. This x and that one over there, they cancel. Then these two, this one here and that one there, there are two fractions that I can combine. The denominators are not the same, so first I have to make the denominators the same. So this is the limit as h goes to 0. Then this h will remain there. Then I have plus x minus x plus h over x times x plus h, and this is all over h. So what I've done here is I've combined these two fractions. I have the 1 over x plus h and this one. Let me just show it at the bottom here. So I have 1 over x plus h minus 1 over x. So I make the denominator the lowest common multiple of the two of them, and then you do the cross multiplication. So it's x then minus x plus h. Okay, so this is how I got that one over there. Then we simplify. This is equal to the limit as h goes to 0. In the numerator I have h plus x minus h over x plus h. So you can see here this negative multiplies inside the brackets. The x will become negative and the h will also become negative. And this is all over h. Then this is limit h goes to 0. I have h minus, because these two cancel each other out, give me 0. Now I have minus h over x. This is all divided by h. Then in the numerator, you can see what I have, all the terms. I can factor h out, so I know I'm on the right track. This is the limit as h goes to 0. Then in the numerator, if I factor h out, I'll be left with 1 minus 1 over x plus h. Okay, this is all over h. And if you tried to multiply this in, you would say h times 1 and then h times 1 over that. You'll end up back over here. So always check that you've factorized it correctly. Then, continuing, we have limit as h goes to 0. Now this h and that one will cancel. I'll be left with 1 minus 1 over x plus h. Okay, now we are free to substitute because we will no longer be dividing by 0 when we substitute. And when we substitute, the limit is gone. So I have 1 minus 1 over x, and then I have x plus 0. So this is just equal to 1 minus 1 over x squared. This is the slope or the gradient at any point on the curve. This is the slope of any point on the curve. Y is equal to x plus 1 over x. So depending on what your point is, you will just substitute it into the formula for the gradient, and then you can work out what gradient is. Now let's say we were asked to work out the gradient. Okay, not the gradient. So still part of the same question. It says determine the equation of the tangent. X plus 1 over x at the point x is equal to 2. Now what you should know is that the gradient of the tangent, so gradient of the tangent, this is equal to the gradient at the point of tangency. Okay, so if I know the gradient at x is equal to 2, then the gradient will be the same for the tangent. And a tangent is a line that cuts a graph, that intersects the graph only at one point. So if you have a graph that looks something like that, then a tangent, okay, my drawing isn't so good, but it is a line that touches your graph only at one point like that. So that is what tangent is. So if I want to work out the gradient, sorry, the equation of this line here, what I need to do is work out the gradient of the point. In our case here, it's going to be 2, and then use my knowledge of equations of lines in order to work out the gradient of a tangent. Okay, so we already worked out the formula for the gradient, and it is this one over here. So this is the formula of the gradient. So I need to work out the gradient at x is equal to 2. So I will just substitute. This is, we can write it like this, y prime of 2. This is equal to 1 minus 1 over x squared. This is 1 over 2 squared. This is just 1 minus 1/4. This is equal to 3 over 4. So I know the gradient at the point x is equal to 2 is 3 over 4. That means the gradient of the tangent is also going to be 3 over 4. Now, if I have the gradient and I want to work out the equation of the line, the only other thing I need is a point that is on the line. Now, going back to my drawing, this point here, the point of tangency, lies on the curve as well as on the tangent. So the point here, 2 and some y value, that is a point that I can use to work out the equation of the line. Now to get this y value over here, I will just substitute the 2 into my function f of x, because that is where the two graphs intersect, the tangent and the curve, so their y values are the same. So to get the point, my y is equal to x plus 1 over x, but I'm looking for the point when x is equal to 2. So I have y is equal to 2 plus 1 over 2, and this is just equal to 5 over 2. So the point is this 2 comma 5 over 2. So I have the gradient and I have a point on the line. Now I just use the 1 point gradient formula. So the equation of the tangent, this I will now just use y minus y1 is equal to mx minus x1. So this is y minus the y coordinate of the point that is on the line. This is 5 over 2. And my gradient was 3 over 4. X minus the x coordinate of the point on the line, which is 2. And like that. So you rewrite this in standard form. You get y is equal to 3 over 4 x plus 1. Okay, so that is your equation of the tangent. Now you can also be asked to work out the equation of the normal. So the equation of the normal. Now the normal, I go back to my graph over here. If this is the tangent, then your normal is perpendicular to the tangent. So this is your normal here. It is perpendicular to the tangent and they pass through the same point. You can see f of x, the tangent and the normal, they all pass through that point over there. So this point that we worked out, which was 2 comma 5 over 2, is common to all three of them, and the gradient of the normal is the negative reciprocal of the tangent. So if I know the gradient of the tangent, I can simply work out the gradient of the normal by taking the negative reciprocal. So that is not difficult. Okay, so here my gradient m, this will be the negative reciprocal of the tangent. So it's negative 4 over 3. The point is the same because they all pass through the same point. So this is still 2 and 5 over 2. Then I just use the formula y minus y1 is equal to mx minus x1. So this is y minus y1. This is 5 over 2. M is negative 4 over 3. And then x minus 2. And you can work this out. This is minus 4 over 3x. That is 8 over 3. Let's see. Eight over 3 plus 5 over 2. This should give you 31 over 6. Okay, and then that is your equation of the normal. So other times you'll be asked to work out the equation of the grade of the tangent, and other times the equation of the normal. So you should know how the normal and the tangent are related, just that they're perpendicular to each other. Okay, then some notation. We use these interchangeably sometimes to mean the same thing. So I will say y prime, that means the derivative of y with respect to x. Could also write dy dx. This is also the derivative of y with respect to x. F prime of x d dx of f of x. This one just means differentiate f of x with respect to x. So that's what it means, but you're doing exactly the same thing. And also the derivative with respect to x. So when you see all these, they're just different ways of writing the same thing. So depending on whatever book you're reading, you may see it written in one of these ways, but they're all doing exactly the same thing. Okay, let us show that if y is equal to cos x, then y prime is equal to minus sine x. Okay, so what that means is if you have your graph y is equal to cos x and you want to work out the gradient of any point on the curve, I want to work out point over there. To work out its gradient, this is just equal to minus sine of that point that I have. Okay, so we are going to use the first principle. We know that y prime, this is the limit as h goes to 0 of f of x plus h minus f of x over h. So this is the definition. Now we substitute. This is the limit as h goes to 0. Now f of x plus h, that means wherever we have x, we substitute x plus h. So instead of cos of x, I will have cos of x plus h. And then f of x, this is just equal to cos x. And this is divided by h. Then we know how to expand this one over here. We did it in trigonometry. This is the limit as h goes to 0. This is cos x, cos h, minus sine x, sine h, minus cos x. And this is all over h. Okay, so what we can do is, if you look at the first term here and the last term, they have cos x in common. So you can group those two together and factor out cos x. So this is the limit as h goes to 0 of cos x. And then here I will have cos h minus 1. And then I have minus sine x. Okay, my space. Minus sine x, sine h. This is all over h. Now the thing about limits, we did this already when we're evaluating limits to infinity. For example, when we had something like this, the limit as x goes to infinity, then we had x cubed, x squared minus 1 over x squared plus 1. We say this is limit x goes to infinity, and then I have 1 minus 1 over x squared over 1 plus 1 over x squared. And then I said this limit remains 1, this one goes to 0, this one remains 1, and then this one goes to 0. And then I added everything together. Now this is the same as working out the individual limits and then working out your final answer. So what I mean by that is when you have a sum or a difference like this, the limit of a difference is just the difference of the limits. So this is equal to the limit as h goes to 0. Now the first one was cos x, so I have cos x. Then I have cos h minus 1 over h, sorry. And then the second one, I have plus. Here it is sine x, sine h, plus the limit as h goes to 0 of minus sine x sine h. This is divided by h. Okay. Oh, why did I write it there? Okay. So I have it over there. Then what I do is this cos x has nothing to do with h. So whether h is going to 0 or whatever is happening to h, it has no effect on cos x. So you can take it out of the limit. So this is cos x limit as h goes to 0 of cos h minus 1 over h. And then here again, this minus sine x, it has nothing to do with h. So whatever h is increasing or decreasing to has no effect on sine x. So you can also take it out. So I have minus sine x. Then I have the limit h goes to 0 of sine h over h. Now these are special limits that we need to know, but you can try it on your calculator and you will see that this is true. This first limit over here, this one goes to 0. So you can try it with different values of h over there, substitute them getting closer and closer to 0. You will see that this value, cos h minus 1 over h, is getting closer and closer to 0. Now this one over here is also a special limit. This is actually equal to 1. So again, you can try it with values of sine that are getting closer and closer to 0. You will see that your answer is getting closer and closer to 1. So what we are left with is this cos x times 0 minus sine x times 1. This is just equal to minus sine x, which is what we were asked to prove or to show. There's the other one that is done in your books, so you can go through that one, that if your y is equal to sine x, then y prime is equal to cos x. So you can follow that example and see how this is true. So what this means is if I want to find the gradient at any point on the sine curve, the answer is just cos of that point that I am at. Okay, now to make derivatives a little bit easier, there's a table that is provided for you in the textbook. This is on page 139. So it gives you a variety of functions. So we have, for example, I'm not going to write the whole table, but here you have your f of x, and then it tells you what the derivative of that function is. So the first one is if you have x to the power of n, so you'll have x raised to an exponent, which is a real number, then the derivative is just nx to the power of n minus 1. So the n comes down and multiplies with the x, and then the exponent at the top decreases. So you can follow along the table as we are doing these questions. So with this, it makes it much easier. You don't have to use first principle for everything. Okay, so there are shorter ways. Now let's look at the exercises that we have. This is exercise 12.7.2. Let's start with number 1. So we have y is equal to 10 to the power of 23. Now if we look at our table, this one is actually not anywhere on the table, but we can prove it using the first principle, and then from thereafter we should know what it is. Now 10 to the power of 3 doesn't have an x in it, so this is a constant. So we have something like this, y is equal to k, or let me write f of x. F of x is equal to k. It's a constant, so it's like a horizontal line. So whatever you put into the function, you will always get k out. So if we want to find f prime of x, this is the limit h goes to 0 of f of x plus h minus f of x over h. And this is just the limit h goes to 0. Now f of x plus h, we said, is also equal to k because your function is constant. Whatever you put into the function, you always get k out. And then minus f of x, which is equal to k, and this is equal to, it's over h. So here I have the limit as h goes to 0 of 0 over h. This is equal to the limit as h goes to 0 of 0, and this is equal to 0 because 0 is a constant. So whatever is happening to h doesn't affect 0. The answer always remains 0. So here, when we're given y is equal to 10 to the power of 23, y prime, this is equal to 0 because my function is a constant. And if your function is constant, it's a straight line, the slope of this line is 0. Okay, so you're not going uphill or downhill, you're just staying straight. Okay, number 2. Let's say we have y is equal to x to the power of 20 plus 100x plus pi. Okay, so here we have a sum. So what we'll do is we work out the derivative of this one, the derivative of that one, the derivative of that one, and then add the derivatives together. So the sum of a derivative is the derivative of the individual sums. So 10 to the power of 20, if you look at your table, that is d1. So the 20 will come down and then the exponent will decrease by 1. So here y prime, this is 20, it came down, and then x to the power of 19. So this is the derivative of that one. Then I add it to the derivative of the next one. The derivative of the next one is similar to d1, except that there is 100 over here. Now what we'll do is, this one has exponent of 1. We'll do the same thing, differentiate this x to the power of 1 and then multiply it by 100. So the 100 will stay there, and then the 1 will come down, and then I will have x to the power of 0. And then pi is a constant like the one we just did previously. The derivative of a constant is equal to 0. So we can simplify this. This is 20 x to the power of 19 plus 100. X to the power of 0 is just 1, and then plus 0, that is my derivative. Look at number 4. I have y is equal to 1 over x plus the square root of x to the power of 3 plus e to the power of 3. Okay, so I look at the first one, 1 over x. 1 over x falls under d1 because it's x to the power of 1. So I'll rewrite it, x to the power of minus 1. And then square root of x cubed also falls under d1 because this is x to the power of 3 over 2. And then e to the power of 3, that is just a constant, so its derivative is going to be 0. So working out these derivatives, now y prime, for the first one under d1, the minus 1 should come down. It'll multiply the x, and then the exponent of x will decrease by 1. So I have minus 2 over there. And then the same thing with that one. It doesn't matter that I have 3 over 2. This is an integer. This is not an integer. It must still come down, and then the exponent should decrease by 1. So I have 3 over 2 x to the power of a half. 3 over 2 minus 1 is a half. And then e to the power of 3, that is a constant. So the derivative of that one is 0. Then you can just rewrite this. This is negative 1 over x squared plus 3 over 2 square root of x. and then that is your final answer. Okay, let's look at number 5. Number 5, I have y is equal to pi sec x plus ln of x to the power of 13 minus cos x. Okay, so here, if I look at the first term here, pi sec x, I go to my table, sec x is d10, the derivative of sec x is sec x tan x, and then I will multiply it with that pi. So when I have a constant multiplying a function, the derivative is just that constant multiplied by the derivative of the function. And then this 13 over here, we know from our laws of logarithms is that it can come down. So I can just rewrite this function. I'll have y is equal to pi sec x plus 13 ln of x minus cos x. Okay, and then the derivative of cos x we proved is minus sine x. And there it is, D7 on your table. So work out the derivative. So y prime, this is equal to pi times the derivative of sec x. This is sec x tan x. Then the derivative of 13 ln of x, this is just 13 times the derivative of ln of x. Ln of x is d4 on your table, so it's times 1 over x. And then minus the derivative of cos x. The derivative of cos x is minus sine x, so it's minus negative sine x. So this minus is that one over there, and this is the derivative of cos x. Then you simplify as far as possible. This is just equal to pi sec x tan x plus 13 over x. Then I have plus sine x. So you can see I'm using the table. While you're still getting used to it, have the table there next to you, and then go down the list. Say, is it this one? Yes. Is it this one? No. Move on to the next one. Okay, let's look at number 6. We have y is equal to e to the power of x plus x to the power of e. Now, with this one, we have e to the power of x. E to the power of x is d2. On the table, the derivative of e to the power of x is just e to the power of x, so it doesn't change. And x to the power of e, that is d1 on your table, so the e will come down and then the exponent will decrease by 1. So y prime, this is e to the power of x plus the e will come down, the x will stay like that, and then the exponent of x will decrease by 1. So this is how you can write it. You can use your laws of exponents to simplify it. Have I don't know if this will look better than what we have. So we have e this and then over x. You can also write it like that, but that's just using the laws of exponents to simplify it if you don't want any negative exponents, but not much of a difference. And let's look at number 8. We have y is equal to 10 to the power of x. Y is equal to 10 to the power of x. That is number, it's D3 on your table. And the formula of that, or how we have to rewrite it, this says, this is y prime. Now in this case, from your table here, a is equal to 10. Okay, so just substitute a into the column of the derivative. So y prime, this is just 10 to the power of x times ln of a, which is 10. Okay, just like that. And Okay, then number 9, it's not difficult. Number 9 and number 8 are pretty much the same, except that with x to the power of 10, the 10 will come down, then you're left with x to the power of 9. Let's look at number 11. We have y is equal to log 4x. Okay, this one is D5 on your table. So it's D5 on your table, and this, in this case, A is equal to 4. Now, you can see where they got it from by changing the base of the logarithm. So if I wanted to change this to ln, I would have ln of x over ln of 4. And this is just the same as 1 over ln of 4 times ln of x. This ln of 4, 1 over ln of 4, this is a constant, it's a number multiplying by a function of x. So if I want to work out the derivative of this number here, multiplying by my function, I should just work out the derivative of my function and then multiply it by my constant. So y prime, this is just equal to 1 over ln of 4 times 1 over x. So the derivative of ln of x, that's d4 on your table. So this is equal to 1 over x ln of 4, which is the same as d5. So you can see d5 is derived from d4. Okay, that was number 11. Okay, let's look at number 17. I think we can do just one more. Let's see, one more. Okay, number 17. So here we have phi. This is equal to sine theta minus cos theta minus theta squared. So here you must think of your phi and theta as your y and x. So this would be your y, and then this one here would be your x. Okay, so we can use different letters. It's not always going to be x and y. You can have theta, phi, and whatever other variables. But the method is still the same. So if I want phi prime, now sine theta, you go to your table. This is d6. So the derivative of sine theta, this is just cos theta. And then cos theta on your table, this is d7. The derivative of cos theta is negative sine theta. So when negative sine theta multiplies with this negative over here, I will get positive sine theta. And then the derivative of theta squared, this one here, the 2 will come down, and then at the exponent you decrease it by 1. So this is minus 2 theta to the power of 1, and that is it. So the ones that I didn't do, go and try them. You're just using the table. See, is it this one on the table? If it is, use it. If not, move on to the next one. Okay, do we have any questions before we call it a day? Or everything is perfectly understood?
Excuse me, ma'am.
Yes.
Just a question on the resumption of classes. So do we go back on the 3rd and just follow the timetable?
I have not heard anything about face-to-face classes resuming. So I think we will still continue with online classes. Because I know it says that schools will open, but it's only grade 12 and 11, I think. And as far as I know, NUST will continue with online classes. Yeah, but if we do go back to face, we'll just follow the timetable as usual.
Thanks, ma'am.
Okay. Right. if there are no other questions, then I will see you guys tomorrow. That is at 9:30. Yeah. Okay. Have a good day.